can be insoluble in excess. Full stop. That means that if it fails to dissolve, then you will not be able to obtain a solution. You will just say a white or a blue or a green or a brown precipitate. Let me insert the word precipitate here. Precipitate insoluble in excess. Please, from here, you stop. Do not say to form a solution of this color. No. If it has failed to dissolve, it will not form a solution. Then, you may also get no observable change completely. It is very possible for you to get no observable change because some of those cations may not give any observable change with the reagent. That means it may not be able to form a precipitate. But we say that if it is with sodium hydroxide and you see later on that you are supposed to heat the mixture, then simply know that in this case you are testing for ammonium ion and you are likely to get ammonia gas. So these are our expectations here when we use solutions of sodium hydroxide and then ammonia solution, which is also referred to as aqueous ammonia. So this one is just generally what we shall be able to do. So the test instruction will say that to the solution under test, they may not tell you that you use exactly 1 cubic centimeter. 1 cubic centimeter, but a candidate has to know that he or she needs to use something small that responds very fast to the reagent. If you have used a lot, then when you first make this first part here to see if a precipitate forms, then coming to the second part, that you should add a lot at once, your test will already be full. And the reagent solution may not be enough to give you the second observation. So to evade that, let us just use a small amount of the solution under test. Like 1 cubic centimeter, which I said is like an equivalent of a 1 centimeter length of the test tube. That will be enough. So the instruction says you add the reagent solution of either sodium hydroxide solution or ammonia solution dropwise until in excess. So I say that to effect this one here very easily in 5 seconds, first add 1 to 3 drops. Ta, ta, ta. You will be able to see a precipitate if a precipitate can form. Then confirm if the precipitate is soluble in excess or not by adding a lot of the reagents. Just squeeze from your dropper. If it dissolves, yes, then that is it. If it doesn't dissolve also, please make sure that you make a thorough confirmation by so adding some more of the reagents. And if it really fails to dissolve, then that means that it is insoluble in excess, and we may get any of these observations here. A precipitate of a given color soluble in excess to form a solution of some color. So take note of this. I can have a white precipitate soluble in excess to form a colorless solution. You may also get a precipitate of a given color, the color you will put it here, insoluble in excess, and you stop there. It will not form a solution, it is insoluble in excess. Then you may also get no observable change. If you have got no observable change, you stop there. In case the instruction goes ahead and say that you heat, more especially I said if it is for sodium hydroxide solution that you have added, if it says that then you heat, then when you heat, expect to get ammonia gas. You should be ready with your nose to get the smell of that particular gas which is produced, the ammonia. And you should also be equipped with your moist, both moist blue and red litmus papers at the mouth of the test tube as you are going to heat in this case. Because if the ammonia gas is produced, it will be able to turn the moist red litmus paper to blue since it is an alkaline gas. So this is how we prepare solutions. In our next session, we are going to specifically the use of sodium hydroxide solution and the use of ammonia solution in detecting the cations strictly, and we shall be able to see how each of these cations respond to these reagents here. So this is Step Talks Education. Thank you for watching.